The fundamental counting principle is a way to determine a certain number of arrangements or combinations of something, but it says that if there are A ways, so some number of ways for one activity to occur, and B number of ways for a second activity to occur, then all you guys have to do is multiply those number of ways for each event or activity together to find the number possible for both of them to occur. So it says, Andy has asked his girlfriend to make all the decisions for their date on her birthday. It says she will pick a restaurant and an activity for the date. So Andy will choose a gift for her. The local restaurants include Mexican, Chinese, seafood, and Italian. The activities she can choose from are putt-putt, bowling, and movies. Andy will buy her either candy or flowers. So depending on the number of events or activities occurring depends on how many things you have to multiply together. So if we're looking at the restaurants, the activities, and then the candies or flowers, that's 3 things to multiply together. So I'll start with the restaurants first. All we really do need to do is multiply everything together to get that it's 4 restaurants times 3 activities times 2 either candy or flowers. So 4 times 3 times 2 would give you 24 different decisions that Andy would have to make. But if we draw a tree diagram, we can get to the same outcome. So if we start with the restaurants, Mexican, Chinese, seafood, and Italian. And then we do the activities. And I'm just going to use letters for short. So putt-putt will be P, bowling will be B, and movies will be M. So 3 for each of those. And then based off of if he chooses one of them, he'll have to then choose if he wants candies or flowers. So if you guys count up the number of items at the end of our branch, we have 1, 2, 3. So candy, 1, flour, 2, candy, 3, flour, 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 things at the end of our tree diagram. We also got that from multiplying the events together. So both ways you're able to do that. So you're literally just counting the number of possible ways or number of possible decisions or combinations that they can choose from. So number 3, it says determine how many different computer passwords are possible if digits and letters cannot be repeated. Given the password must be 4 digits, 0 through 9, followed by 2 letters. How many letters are in the alphabet? 26. So 0 through 9, so 1 through 9 is 9, include 0. So that's 10 possibilities for the digits. And then the letters have 26 possibilities. So this computer password wants to have 4 digits. So 1, 2, 3, 4 digits, followed by 2 letters. So if we can't repeat, that's saying that the very first spot in this password, you can choose from all 10 digits to go in that first spot. But once you've now chose one of those digits, to be used, the second digit, you now only have 9 options to choose from. The third one, you'll have 8 to choose from. The fourth one, you'll have 7 to choose from. So those values in red make up the 4 digits you're going to use in your password. Now, the letters, 26 options to choose for the first letter, and then once you've chose a letter, it doesn't matter which one, you'll have 25 to choose from for the second letter. Now, if it said it could be repeated, you would have done 10, 10, 10, 10, and 26, 26. But when it says it can't be repeated, your options go down each time. So, all you do is multiply it together, and you get 3,276,000 possible password combinations. So just be, again, paying attention to if you can or can't repeat things, and you just have to think about what you're being allowed to use from. So number 4, it says, we're talking about license plates now, that have 3 letters followed by 4 numbers 0 through 9. So if the same letter or number can be repeated, how many can be made? How many license plates can be made? So for your letters, 3 letters, they can be repeated. So you can use all 26 options for each letter. So you could have DDD or XXX or NNN. And then for your numbers, we would have 4 numbers. And if we can repeat them, it'll be 10 times 10 times 10. So you multiply it all together, and you get 175,760,000 combinations or possibilities for license plates that use 3 letters and 4 digits or 4 numbers.